There are a few skills that you learn in Algebra 1 that are going to be pivotal skills, kind of watershed skills, right? And I've used that expression. Y'all are familiar with the watershed, the terminology of watershed. So you've got a big hill, right? A ridge, so to speak. It's like this, and the water that falls off, the water that lands here is going to fall down this side, or it's going to fall down this side. And so over here we have good mathematics students. And over here we have everybody else. Okay? All right. So there's a lot of skills. We call them I call them watershed skills because you either get the skill and you become a better mathematician, or you don't get the skill and you are forever limited in your ability to do mathematics.
That sounds great.
Yes. So you've passed a lot of those, and you're here in Honors Algebra 1 class. But what we're going to look at today is the most important skill to being successful in math beyond Algebra 1.
Great.
Algebra 2, into even the other ones. Okay? It starts out simple, but it gets more complicated as we move. So don't be lulled to sleep by the ease of today's lesson, because it gets more difficult quickly. So anyway, what we're looking at today is factoring polynomials. Specifically, factoring trinomials. Okay? Now, factoring trinomials, all right, here's an example of a trinomial. 5x squared plus 10x plus, that doesn't work. 5. Okay, so what we're talking about today is going to be factoring expressions like this. Okay, we want to break it down into something that is being multiplied, right? That's the purpose of factoring, is to break this up into pieces that are being multiplied times each other. Okay, now there's a lot of applications that we've had to factoring trinomials. What are some things that, or factoring polynomials, what are some things that we've done so far with factoring polynomials? What do we use factoring for? We could use factoring to find the GCF, the greatest common factor. We can also use factoring to find the least common multiple, which is kin to getting a common denominator. What else have we done with factoring?
So you factor terms so that you can cancel out? Yeah.
So we can simplify
Terms.
fractions. That's right. So we've used factoring to simplify fractions. This is one of the big skills that factoring is used for, right? Because you can only simplify fractions by canceling common factors between the numerator and denominator. We can't cancel terms or parts of terms, only factors or parts of factors, okay? Not parts of factors. You can only cancel factors. All right, so to simplify fractions, you have to cancel common factors, and to find the common factors, we have to factor, right? All right, so factoring, that's what we've used it so far for, but it's going to end up being huge skill in solving equations, right? Remember that all of algebra it's the branch of mathematics where we study the skills. Algebra 1, we're learning the skills that are going to be necessary to solve all types of equations, particularly finding all 5 solutions to a 5th degree polynomial, all 4 solutions of a 4th degree polynomial, the fundamental theorem of algebra. Okay, so that's what we're headed for. So this skill is ultimately going to be very important in a lot of things that are leading up to solving some difficult types of equations. Now, let's look for some patterns. So if we're factoring trinomials, let's work backwards from factoring, which is what? Multiplying, right? So let's look at a few. Let's multiply x plus 6 times x plus 3 and see what we get. Now, you might be at this point able to multiply that without really even showing a lot of work because you know the process of doing it forward, right? So what is the product of x plus 3 and x plus 6?
X plus 18.
X plus 18. So what we're going to do today is take a trinomial that looks like this and put it back into factored form. So what is the pattern that you see that might help us do that? What's the relationship between the product here and its factors? Ask me.
Like 6 and 3, you get 9, 3 multiplied.
6 added to 3 is 9, right? 6 times 3 is 18. So the factors of 18 that add up to be 9 are 6 and 3. Okay? What about this one? X minus 7 times x plus 4. All right, what do we get?
X squared minus 3x minus 28.
Okay, does the same relationship exist up here?
Yes.
Same relationship exists in this problem that we saw in the previous one? Because in mathematics, we're looking for patterns and methods that will work all the time. All right, so what we did up here, is it true here? What are the factors of negative 27 that add up to be negative 3?
Negative 28.
28, thank you. Good.
That's great.
Negative 28, I'm sorry, I was totally daydreaming about Louis' surgery tomorrow. That's just killing me in more ways than one. It's a lot of money.
Yeah.
Okay, negative 28. What are the factors of negative 28 that add up to be negative 3? Negative 7 and positive 4, right? Negative 7 times 4 is negative 28. Negative 7 plus 4 is negative 3. So the pattern works again, right? All right, let's look at one more. Let's look at x minus 5 times x minus 6. All right, what do we get? Liam?
X squared minus 11x plus 30.
Does that, y'all agree with that? Does the pattern still hold true here? Now, what's different about this one?
They're positive and negative.
These are negative and then positive, right? Both of the ones up top are negative. So that's a pattern that we need to look for also. If we have two negative signs here, they will add to be a negative, but they will multiply to be a positive, right? So that's going to kind of come into play. So do y'all think y'all are ready to work backwards now?
Yes.
Look at some examples. Okay, so let's look at a few examples of factoring trinomials as the product of two binomials. All right, write it down, and then let's try to ask the same questions we were asking a moment ago to work this backwards.
It's the same with the, it's the same what we worked the first one. Were the 3 that we worked?
Yeah.
We worked this one?
Yeah, not the other one.
Sorry. So what is this going to factor as?
X plus 6 times x plus 3.
All right, will it work any other way? Could we use any other factors of 18?
No. 9 and 2, but 9 and 2 equals 11.
If we use 9 and 2, would that work?
No.
Because that gives us a middle term of 11x. Liam?
If we actually switched around, like had x plus 3 times x plus 6, that wouldn't be wrong.
No, it would not. So we couldn't use 1 and 18.
No, because 18 plus 1 does not equal 9.
Right. So the only factor pairs of 18 that will work for factoring this is 6 and 3. Now, Liam just asked the question if the order matters. Does it matter if we do x plus 6 first? Why not?
When you multiply, it doesn't matter.
Because the commutative property of multiplication says that we can multiply things in different order. So the order that we multiply these two things is not important. Okay? Now, one thing that is important is to always check your answers. X times x is x squared. 3x plus 6x, that's 9x, and 6 times 3 is 18. Okay, so that's going to work for us. Okay.
Oh my gosh.
It's like that nerd that got beat up.
It's polynomial man. No. Just a little chin hair down here and some eyes. We could put some glasses on him here.
Yeah, but it looks like that nerd that got beat up after school.
Oh, man, don't talk about nerds that get beat up after school. All right, x squared minus 5x plus 4. Okay, now this was a pattern that we mentioned in one of the problems that we worked, right? Was it the second problem or the third problem that we worked? The middle term is positive and the third term is, the middle term is negative and the third term is positive.
So it'll be x minus something times x minus something.
Yeah, so if the pattern holds true, it's got to be, right? Because we're multiplying to get a positive, but we're adding to get a negative. So these both have to be negative, right? What's it going to be? X minus 1 times x minus 4. Does that work?
Yep.
I believe it does, right? What's x times x?
X squared.
X squared minus 4x. Because there's just really only a couple things to try, right?
Yeah.
2 and 2 or 4 and 4. 4 and 1. That's it.
4 times 1 equals 4, but 4 plus
The negative 1 times negative 4 is positive 4.
then negative
That's why I
1
went ahead and
plus-
did x minus.
Okay?
X minus something. Just
She's figured out quicker than the rest of us did. Sorry.
You good?
looking at me.
Because we're waiting on you to get it.
Are you done?
I've already been in this class.
You'll be waiting on.
Yeah. Liam came to 5th period. Okay. X squared plus 3x minus 10. All right, now this one's different. This one we're adding to get the two things to get a positive, but we're multiplying to get a negative. If we're multiplying to get a negative 10, that means one of them is going to have to be negative and one of them is going to have to be positive. All right, so we got to make sure the thing that you would mess up on here is getting the positive and negative term parts mixed up, right? So, does everybody think you got it? What'd you get, Mary Helen? No? All right. Well, wait. Wait. Give everybody a second to look at it. We're multiplying to get negative 10, adding to get positive 3.
Okay.
I got it.
checked it.
There we go. I just searched in wrong.
I think I have
It
it.
made it wrong. But I got it.
Okay.
Almost tricked me, Mr. Hit.
All right. So what would we get here, Mary Helen?
I got x minus 2 times x plus 5.
X minus 2 times x plus 5. Is that right?
Yep.
Yeah, that's right, because this gives us x squared, right? 5x minus 2x, that's 3x. And then negative 2 times 5 is negative 10. So that works. Now, I want you guys to get used to using this process for checking your answers. Y'all listen carefully. Get used to using this process for checking your answers, because this is going to kind of play into what we're going to do on the more difficult problems. Do you really have to do all this little detail of checking the answers on these simple ones? You don't, but we're building a process that's going to be very useful for later. Okay? So make sure, like when I checked your homework on Monday, it would just make me happy to see this, your problems look like this. And you can even draw the teeth, right? But I want your problems to look like that. Okay? All right. Mater. Yeah.
She put her down. What?
Like a horse? All right, x squared minus 7x minus 8. X squared minus 7x minus 8. Now we're multiplying to get a negative still, right? Which means one of the things we're multiplying is going to have to be negative, and one of the things we're multiplying is going to have to be positive. All right. So, you got it, Brooklyn?
I think so,
All right. What is it?
but probably not.
No, what do you got?
Wait, let me check it.
No, just tell me. We'll check it together.
X minus 8 times x plus 1.
That's what I got. Yeah.
Yay,
Good. Okay. So we're looking for the factors of negative 8 that add up to be negative 7. So we're subtracting, because the reason we're subtracting is because the two terms have different signs. And we're going to keep the sign of the bigger one. So if our middle term's negative, our larger factor has to be negative. In the last one, our middle term was positive, which means our larger factor has to be positive. Here, the larger factor has to be negative. Okay? So you learn to see these terms, or these patterns that take place, and then we're going to have x times x is x squared. And I love that you wanted to check it. That's 1x minus 8x, which adds up to be negative 7x, and then negative 8 times 1 is negative 8. So x minus 8 times x plus 1 works. All right? Now, this next example is going to look really foreign. Okay, but see if you can figure out what this is going to look like. Now, we're not going to do a lot of problems like this because this particular problem falls firmly within the ranks of you're just practicing a skill here. There's no practical application to factoring this expression other than just practicing the skill of factoring. Okay?
What are you trying to do to me?
I'm confused. I don't really know what I'm going to do.
Oh, I know.
Good. No, you should. I mean, just it falls in line with what we've been doing. If you ignore the y and then just find a way to put it in, then you're going to be okay.
Ignore the y?
Momentarily.
Crap, I messed up. I know what the number should be.
What should the numbers be?
Oh,
Wait,
3 and 2.
Okay, so if this was just x squared plus 5x plus 6, we know it would be x plus 3 and x plus 2, right?
Oh, I got.
Then what would you do?
6 and negative 1.
Can't do that because nothing multiplies to being negative, right? 6 and negative 1 won't work. Now, how could you get 6y squared out of this?
Middle y, 3.
Yeah, that's what I did.
And then 2y.
That's what I did.
All right, let's see if that works. Right? X times x is x squared. That's 2xy plus 3xy. That works, doesn't it? That's 5xy. And then 3y times 2y is 6y squared. So x plus 3y times x plus 2y is the factorization of that. Now, it's a good skill. You can learn to practice factoring. The reason that I say that there's no practical application to that is because if we looked at this as a function of x and y, which we're not going to do in we're not going to do this in, if we looked at the graph of that as a function of x and y, it would be something strange. not something that you're ever going to look at, okay, or do. Now, you will look at functions of x and y. They'll be, like this, x minus 3 squared plus y minus 2 squared equals 25, for example. That's a circle with a radius of 5 and a center at 3, 2 on the x-axis, in the coordinate plane. So we'll look at functions in two variables, but none of the functions that you'll look in two variables will look like this. That's why I say there's no practical application to it in any of your lower level maths. In calculus, you'll do some stuff with it, but it doesn't involve factoring. So, yeah, it might be on your homework. It's good to be able to factor these, but it's just not going to be real practical for us. Okay. What'd you come up with? Mm-hmm.
Okay.
X plus 3y times x minus 1y. Yeah, you could just do x minus y. Mm-hmm. Does that work? Because the factors of -3 that add up to be +2, and then the y is just kind of an afterthought. Oh, we need a y squared. All right. All right. What would you do with this one?
Put it in right order first.
Put it in right order. What is right order called? It's called standard form, right? So we want this to be in standard form to factor it. And that's going to be x squared minus 4x minus 21. Yeah, it's really not. It is, but don't let it lull you to sleep, okay? Because it goes from pretty easy to pretty difficult.
Pretty difficult in this lesson?
No, later in the unit. So when we start factoring things that look like 6x squared minus 13x minus 8, it's a lot different.
Oh, yeah.
No, sit down. Sit down. Why is that more difficult?
There's not really common fact.
Because we have choices for here. What you multiply to get 6x squared could be 2x. It could be 2x and 3x, or it could be 1x and 6x. And then there are no factors of 8 that add up to 13. But it's now it's a combination of these factors. We use -48, factors of -48 that add up to -13. It just gets a lot more complicated a lot more quickly.
That's crazy.
Later in this unit. No, it's not LCM related. All right, so what would this factor as? It's pretty easy once you put it in standard form.
X minus 7 times
X minus 7 times x plus 3. All right, and you check that. That's x squared. It's 3x minus 7x. That's good. -7 times 3 is -21. We're in good shape. All right, always check your answers to make sure it works. Now, I don't really love this next problem, but you see this in Saxon. These are the types of questions that they like to give you an application that's not really an application. But they want you to evaluate this expression and then evaluate its factors. Okay, so they want you to evaluate the expression, evaluate this when x is 3. How would you do that?
You just plug X.
You just plug 3 in, right? So you get 3 squared plus 5 times 3 minus 14, and that's equal to 10. And then they say they want you to evaluate its factors also. So what are the factors of this?
Oh, we're doing two things in one.
Oh,
Two things in
okay.
one. There's that and, right. We're going to do both things. X plus 7 times x minus 2, right? And then it says to evaluate its factors. So if you want to plug the 3 in there, you get 3 plus 7 times 3 minus 2. That's 10 times 1, which is still 10. It's just a confirmation that this expression is equivalent in factored form. And that would be true for whatever value you put in it. Probably. Usually when there's an example problem, you'll see a homework problem or two like it. All right. Now, the homework that you're about to see, you guys have 20 minutes to work on, which is good.